Hello, hello, and welcome back to the stream. All right, today we're going to be going back into the whole meta agents idea. Yes, that's just like me to jump around all over the place, willy-nilly like that. Willy-nilly. I found this interesting new, so just before we get started, right? I'm going to go over a couple of things on this stream. It might be a long one, I'm not too sure. We'll see how it goes. There's a couple of things going on here. One of them is here, let me just those up. So first off, in this panel below, we have Prompt Owl, which is my my language for coding or scripting prompts, basically. And the idea of Prompt Owl is that you can use, so essentially, here we go. In the current idea of prompting, it's like you get an input and then you get an output. And it's like everything is in line. So if I give it a document, it performs the completion of that document. That is normally called completion, or like completion endpoints are endpoints that you call, which are not chat endpoints, which are essentially chat models are models that are designed to read in the chat format. They're sort of fine-tuned for that. And then just instruct models by themselves. So for instance, I'm using Mistral Instruct 7B. Just instruct models by themselves allow you to do continuation on a continuation endpoint. So the main difference between how you prompt in Prompt Owl and how you prompt in just like a, winging it yourself or using a prompting system like LangChain or something along those lines is that Prompt Owl is it's focused on being very small. One of the biggest problems with libraries like LangChain is that they've got a community version now. They've got all this shit going on, and lots of stuff gets broken in updates, and there's like, it's kind of willy-nilly, a little sloppy. So I decided that at this time last year, I essentially decided that I needed my own language if I was going to continue writing production code. So I set out and I wrote this. And it's a very nice piece of code. I think I'm really proud of it. It is one of my projects that I've finished, which is amazing. And the idea here is that you just use curly braces. So it's kind of like the same thing as when you're using, in Python, you're using like the whole scripting prompt template, or sorry, string template type of a deal. The string template library. So it's a very similar syntax. The only difference is that you can declare variables. There's only actually one major difference between this and normal prompting, which makes all the difference in the world in how easily I can write prompts, like which do complex tasks, just in the prompt alone without going back to Python, for instance. So here's an example: creative writing, storytelling, write a short and creative story with a mood. So mood is an input variable that's referenced. Notice that it's not declared above, which means that some prompt, script or whatever, or input variable needs to be fed in there, which is called mood, which has the mood of the story. And then it generates the variable story name, which is 24 tokens long, maximum. And it also has some, like, this has a little bit of give to it, just in case it doesn't stop at that point in time based off of your prompt. And then this is the temperature. So in this case, since it's a creative thing, we want to up the randomness, since it's not so important for everything to be precise or exactly follow the instruction. And then we have a story type, story archetype, and then it goes along the same thing. This one's 12 tokens, temperature is down to 0.4, etc. And then you write the story. And one of the nice things about this is that it does a lot of extra stuff in the background. So all of these things come out as actual data in a JSON. Yes, PrOwl was a quine. Where's the, okay. So yeah, this JSON is. So it shows you the usage as well as the actual data. So user request, value, high highs, Mount Everest, history, blah, 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 usage, what was used for that variable. So it gives you back very, very detailed information, and you could break down that information in sort of any way that you want. We can get into a couple examples later, but this is not actually what this stream is about. This is just sort of showing you guys what I've built for this. Makes it really easy to do stuff that tree of thought, et cetera, and it really is great because it has a command line interpreter as well. So it lets me just write up a prompt. Like I was just literally working on the Godel prompt, So yeah, let's just dive into it. Like this is my prompt here. Gödel's logical completeness. Let me just Alt-Z this, Alt-Z. All right. Assess the user statement and use Gödel's incompleteness theorem to determine if it's logically sound and mathematically complete or not. User request. User request is the variable that gets input. I have a script. So the other thing about PrOwl is that it has a stack, essentially. And the stack idea is that you could take scripts and sort of stack them on top of each other, PrOwl scripts, and then let those sort of, so this is an example of using the command line interpreter. Just you give it the folder. Actually, this is kind of outdated syntax as well. Anyway, the point is you give it the folder, and then you give it a list, essentially, of the different scripts that you want to run from that folder. You can make it like atomic so that they don't pass their continuation to each other, and then you can define what stop characters there would be. And usually there's a default stop characters which are like which are set to something like this, which is so that you can actually make it stop when it's trying to generate a new paragraph or something like that, because some of these smaller models get really wordy. So we do our best basically to stop that, because essentially what's going on is that as this fills out, it's actually writing the rest of the prompt with you, so that by the time you get down to here, it's written like a good portion of the prompt that's actually instructions for itself later on down here when it has to answer a question, or over here when it has to answer these questions. So what is this prompt? I just made a Reddit post about it. So the Godel prompt. And there's my prompt, and there's some examples and stuff like that. Hey, 11 likes. What do you know? Good. Good on you. Good job, Reddit. So, yeah. So the idea behind this one is that LLMs hallucinate, and they do it with logic all the time. Chain of thought or tree of thought prompting techniques solve a lot of issues, but sometimes lack actual logical clarity and lead to downstream logical drift in large prompts. So this is where PrOwl really shines, because essentially what I can do here is, I can do a complex guided tree of thought type of a thing, or I'm giving it specifically what I want it to do, and then it's performing that, and then it's doing the next thing, and all of this is just being done in one call to the interpreter, rather than having it be one call to the LLM. The interpreter itself calls the LLM on each of these variables, and then sanitizes and cleans the data, so on and so forth. So anyway, the nice thing is that as you get further and further down, you sort of get into this like groove, into a flow where you can really control, what comes out here at the end. Also, just real quick, let me just make sure that I'm actually streaming on Twitch, because I don't want to be like thinking that I'm streaming and then nothing is going on. So excuse me if this sounds weird. Oh, I think it says I have one viewer, so this is also a good point to check the chat. Hi, chat. Hi, chat. Okay, and can I hear myself? Yep, yeah, okay. I can hear myself. All right, perfect. So, continuing on, moving along. Get back over here. Okay, so how does this actually work, right? I mean, the nicest thing about this prompting method is that if you read the prompt, just like just like, I mean, ease of use, right? First off, the prompt is its own file. So if you have to make updates to it, all of those updates get made in their own file inside of Git. Then you have a blame for all of the pieces of the prompt. It's not written inside of a string. There's so many things, so many things. I don't have to think about prompting while I'm writing Python code, like in LangChain. Like just look at a LangChain example of writing a chain prompt. So they've got like prompt templates, string prompts, right? Okay, so from LangChain core prompts, prompt template, tell me a joke about blah, 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 right? And there's a chat prompt template that they use for that, which is all well and good and everything. But this is all stuff you can kind of just use templating and then use the OpenAI API for. Let's see, custom prompts for LangChain chains. So look at this. This person, and literally everybody who uses LangChain is using Python to write this stuff in. You can't declare a variable in this because you're working in Python itself. So like the variables that you're declaring have to be done between these things, right? And then you have to declare them on the template and so on and so forth. And then you have to come back over here and then load the summarize chain. Then you have to, do whatever it is on the summarization part. That's all, that's all external stuff. Map re-rank. So like, here it feeds them some examples, few shot examples, and it does this. Those are just like single prompts, and a question prompt and a combined prompt, right? Okay, so essentially, like, the other nice thing that you could do in PrOwl is like you could declare a variable and then use it down here somewhere saying, okay, I'm going to reuse this variable because I need to use the output of this variable inside of another piece of this prompt, right? And so it's not just a chain itself, right? Like it allows you to make really complex, really guided things. And I'll show you the difference here between running the same query, the same question through Girdle and running that through just like a standard tree of thought and how the answers differ. Because what the Girdle prompt tries to like sort of tries to do is it tries to make it so that you have so it tries to check for we're not trying to figure out if the statement is true or false, but rather whether it is actually logically complete. The answer to the claim's truthfulness is sometimes within the knowledge of the LLM in real-world context, but sometimes in order to be proven true or false, it needs more research, right? So like we're trying to essentially like figure out, okay, if we have one of these small LLMs, right, and we have it running on a chain of, so we have it running like inside of a system where it has to perform thinking, right? This could be a chatbot that that has to be extra smart at something and can take a little bit of extra time to answer, or it can be quite a lot of other things. Like essentially, O1 is just a souped up version of this, except inside of LLMs, the idea is that there's like these levels when you want to get something done. Actually, this is good for over here. So let's say that I have a, let's say that I have a problem, right? So the first level is prompting, okay? Then the second level, I can't see my cursor on there. Okay, the second level is few shot. Oh. Okay. The third level is few shot, and then the third level is fine tuning. Okay. Then from fine tuning, Okay, just still getting used to this library. Then for fine tuning, you've got training. So base model. Okay. So what is this all saying, right? This says that in order to, let's go top down on this. Yeah. So in order to get a problem solved with an LLM, this is the order of priority that you must go through, okay? And what do I mean by that? For solving the problem, the first thing that you're going to try to do is just essentially write a prompt. And this is following the path of least resistance, right? That is great for troubleshooting and everything along those lines. So prompting is your first best bet, right? Okay. So it's like, okay, if I just ask the model directly something and then it's not giving me what I want, then I need to structure my question properly. And then that's just like prompt engineering essentially right there, right? Another big part of prompt engineering is few shot. So when you want to do something which is specific, like I was working on this thing over here. Where did it go? Where'd my little mermaid chart thing go? Oh my gosh, I have so many things. Oh, there it is. Okay, so in the mermaid chart thing, which I could show you, essentially like what I have it do is I have it make these based off of my input prompt. Now, this is a little bit of encroachment because Mermaid actually in their playground, they have Mermaid AI, which does the same thing. But Mermaid is actually an open source library for JS or whatever. So technically I could make my own, thing that generates Mermaid scripts in some way, either procedurally or through AI. And then like, yeah, using that for showing the chart directly on whatever interface or something like this. And I kind of have a couple of ideas around that too. Like instead of doing all of this myself when I'm trying to like talk about a thing, I could have like essentially just an LLM sort of assistant that's like listening to my voice, everything that I say, because there's this whole thing with live captioning. So I could use a live captioning system to feed my captions directly into an LLM, like a prompt that would give me back. First, I would probably do like summarization, and then I would feed summarization into the prompt itself, in order to get into the prompt that like, so summarization, and then that would go into something like, maybe I'd make some extra stuff around this, obviously in Python, which allowed it to have like a memory of what I was talking about, and so on and so forth, and perhaps a little bit of lookup for when it needs to think about, wait, do I need to do this or that, right? And then, yeah, okay. So let's just keep going into it. So few shot, the fine tuning part, right? Okay, this is the part where you're no longer prompting. So like if you really wanted to if you really wanted to like say that this was separate, right? You go prompting in few shot, and then within that you've got fine and then base model. So your prompting and few shot sort of a thing is all within prompt engineering, and then this is actually within model training. But so your last final resort is like, I got to make my own model for this, and that's a super expensive, super long, tedious, and non-guaranteed that it's going to work. You're much better off getting your problem solved here. This is the cheap area, and then this starts to get expensive. Fine tuning is cheaper because but I mean, obviously, if you're thinking about fine tuning, what you're talking about is something like I literally used all these examples, and like I just cannot get this thing to get better than just a random, you know, baseline on solving the issue or whatever, right? All right, so I promised you earlier that we would go ahead and do some of these things. Let me just go ahead and see if I've got anybody hanging out. Nobody on Twitch hanging out. Let me see if I got anybody on YouTube chat. Man, YouTube is really munching my CPU, man. Munching it up hard. All right, concurrent viewers 0. I've had 1 view for 18 seconds. Jesus Christ, am I that boring? All right. Okay, so should I even monitor YouTube chat? Yeah, fuck it. Pop out chat. Close YouTube itself. Okay. Hey, Kat. Are you enjoying hanging out with your friends? She's finally being social. All right, so let's go. All right, so nobody to answer in chat. So let's just say, okay, we're gonna use the command line here. I'm gonna just like ploop this up a little bit so that it's like nice, easy to see. So anyone's watching off of a phone later on. Okay, so this is the girdle input, and then I think the other one is over. Jesus, there we go. That's the TOT input. So this one's tree of thought, and the other one is girdle. So let me just like pop in the tree of thought right quick, and we're just going to ask a simple tree of thought question. So imagine that you've got some sort of a process going on, and you've got to use tree of thought to check a claim. Like, let's say that the user says some XYZ thing, and it's like, okay, you have to, tree of thought is supposed to, so this, in fact, is without instruction. It's just telling it to critically think, right? And there's reasons why to use this and why not to, obviously, as well. So when you're asking it to critically think, you're like, oh, what was it? Okay, so check this out. Something like, does a dog have the spirit of the Buddha? Yeah, this is a philosophical question, and it's technically not a logical question, right? But inside of, so let's say though that we're like inside of a process where actually, we need logical thought here. We don't need it pondering about philosophy or something like that. We need it to say like, okay, let's work with the things that we know to be at least provable, right? So this is the completion prompt. The completion prompt is essentially how the bird flies. Through the prompt, it includes my instructions plus the actual answers from the LLM, and then continuing on through over here, answer creatively and all that stuff. All right. So, okay, and then this is the output. So the output is just this output template thing that I have, which just allows you to sort of reformat the output easily. This is also something that I'm using in other places in production, just to make it easier for controlling that without just reusing the same templating system from PrOwl itself, from the PrOwl interpreter. All right, so yeah, seems to be a philosophical or religious inquiry. It may be meant to provoke thought about the nature of consciousness. A dog is likely a common household pet, but it could also be a metaphor for any living being. Spirit of Buddha is a metaphor for, right? This is all good stuff, right? But it's not necessarily guided, and we didn't give it any, fairly. We just didn't give it any actual guidance to say like what is it specifically that you need to critically think about, right? It sort of chose its own things to think about, because it does a think logically and then it does an answer creatively thing. So first it did think logically. What is the context of this question? Is it a philosophical or religious inquiry, or is it a rhetorical question meant to provoke thought? What is the definition of a dog in this context? What is the definition of spirit of Buddha? what is the significance of the question in a larger context of Buddhism? It's actually like taking the time to ask itself these questions and then answer these questions. And all of this stuff is good, especially inside of creative tasks as well, like making something that is, you know, like some of the other stuff that I've been working on last year, which, for instance, adventure mode, which uses prompts for essentially generating a world using LLMs, a world model, so to speak. So, okay. All right, that's all well and good and everything, right? This is all cool, but what is the... I mean, there's nothing here to be proven, right? And it's not telling me that. It's just going forward along with everything, saying, oh, okay, you know, this is that, that's that. Hippies are amazing, and Buddha is green, and dogs are, you know. So, all right, now let's try it with the Gödel prompt. What was it? Let me just go back up to the thing here. Does a dog have the spirit of the Buddha? So, yeah, logical thought. This actually ends up running faster. Well, not faster, but roughly in the same amount of time. But it takes less actual, it's more concise when it's thinking, because it's only trying to think through it logically. So let's just go through it. Does a dog have the spirit of the Buddha? A dog is an animal. The Buddha was a human being. The term spirit is not well defined in this context. The term have is not well defined in this context. The statement does not provide any logical or mathematical relationship between the dog and the Buddha. Is the statement syntactically sound? Yes. Yeah, you can say this, right? Is the statement logically complete? No. Because why? Well, this tells you the further resolution thing actually gives a hint, right? So if you're doing, so instead of using our tokens, let's just say that we have, like, you know, a certain amount of tokens we could spend, right? Like there's an amount of tokens we spend a total of 1424 tokens, right? The other one spent how many tokens? Total tokens 768. Okay. All right, so it took about 7.96, so 8 seconds, and the other one took how many seconds? The other one took 14 seconds. I think there was a problem with this token count. PrOwl definitely does have, whenever tokens go beyond a certain... oh, this has way less completion tokens, though. Yeah, this only has 134 completion tokens. The prompt tokens were 1290. Right, that makes sense. Okay, moving on, though. So this actually had less completion time, and it answered twice as fast. Even though it used up more tokens, it used up twice the tokens, but only 134 of those were completion tokens. So all of the extra cost goes into, this is obviously if you have to pay for this, right? I'm running this off of a local LLM, so that's no big deal. But if you just think about it like compute cost, so to speak, you know, GPU compute, you're dealing with more initial tokens, and then, yeah. All right, so moving on. Yeah, the Buddha is a human being. So for the resolution, this gives us an example of like what it is that we can use to actually further resolve whether this statement is true or if it's just like unfounded or unprovable or something like this. So what is the meaning of spirit in this context? What is the meaning of have? Is there a logical or mathematical relationship between the dog and the Buddha? So these are, for instance, questions that you might ask a person who says this. Or that the LLM might ask the person, right? If it cannot resolve. But let's just try something else with Gödel. Let's try something that's like actually obviously false. So I could say like 75 is both greater than and less than 25. 5. What do we get? Yeah. I mean, it goes straight down into like, so it can determine whether some things that are actually obviously true or false are or not, because it's using Gödel's incompleteness. So the idea is that if you think about the embedding space, I forget what that one video was, but these guys did a really good thing talking about those embedding spaces. Let's see if I could just grab an image. Okay, here's a nice screenshot. So these are some embeddings, right? And this is obviously, this is taken down using something like UMAP or TSNE. We just take it and we make it into a much smaller dimensional representation of the clusters of everything inside of higher dimensional space, which is the embedding space. So you can see that places that are concepts that are semantically closer together in the embedding space are actually closer together in our final chart. So that's it's representative of something like relative distance between everything in the higher dimensional space. Anyway, the point is that looking at this, we can say, okay, well, now that we have that, we should be able to see, we should be able to think in our minds and imagine that when you're using the embedding space of an LLM, like when you're using an LLM, how does it know, like what is it actually doing? Well, it's surfing around this embedding space for the next target, the next path that it has to take to move through that space in a way that's gonna continue what you're saying in the same like essential inertia, so to speak. Let's just say, if you want to think about it visually, right? And so what happens is if you just tell it like, you know, think about this, now answer your own questions. By the time it gets to answer your own questions, you've moved the embedding space. You've moved its like sort of like its cursor in the embedding space to somewhere else in that embedding space, based off of a specific other embedding. So it's kind of like displacing it using the actual words, right? Which means that in this case, what we're doing is we're using the word Gödel, which is, if you think about what they did, right? They scraped Wikipedia. They scraped all of these places to get all this information. Go back over to Gödel. I'll show the mermaid chart thing here in a little bit. I only worked on it a little this morning. So if you think about like the way that this then works and how it gets much more concise and functional answers, is that it's like taking the logic here from Gödel himself. Well, not from Gödel himself, from the writings that are around Gödel, from the context that is around that word, right? And almost everything that's in that context is good stuff. It's not brain slop. It's not stuff that's just, you know, random shit off of Reddit or whatever. Like, of course, people on Reddit talk about Gödel, but for the most part, I'm assuming that like most of the stuff that's online about Gödel is actually has to do with logic and his incompleteness theorem, which we also state right here. So that being said, we're using the bias of the LLMs to our advantage, and then we're using that bias to create a conditioning for answering other questions that further condition it towards the specific answer that we want. So I don't know if that made a lot of sense to you or not. I don't know if it just sounded like a whole bunch of technical rambling. I hope someday somebody sees this video that actually understands what the fuck I'm talking about. So, all right. That's all cool. That's all well and good. So essentially, this says that this, so is 75, I claimed 75 is both greater than and less than 25. Logical thoughts. The statement 75 is greater than 25 is true. The statement 75 is less than 25 is false. The statement cannot be both true and false at the same time. Is the statement syntactically sound? No, it is not syntactically sound. Is the statement logically complete? No. The further resolution, There is no resolution. It's unresolvable. The statement is self-contradictory and cannot be resolved. So what if I said that to, right? What if I said that? I mean, I'll just get anything out of a train of thought if I say like the user statement in that format. So if I were to say, like, just do that same thing, let's grab this. I don't have to tab. So let's do that with TOT. Paste her on in there. Let's see what it randomly, I don't know, like what it just thinks without any sort of guidance whatsoever. What is the context of the statement 75 is both greater than and less than 25? Is this statement a logical or mathematical error? Is there a missing implied qualifier in the statement? What is the intended... What is the intended meaning of the statement? Is there a hidden assumption or underlying context that needs to be considered? So here's the thing, right? If I'm in a, like I said before, like some sort of a creative context where it's like, I'm not trying to figure out if perhaps I'm using this to look at statements that the LLM has made to check and see if it's actually correct or not, and then properly think out the actual correct answer, or realize that it needs some other outside information, right? Instead of doing any of that stuff, what an LLM will actually do is it'll just spitball you. It'll just fucking, be like, well, what's all this stuff, and what's this, and what's that, and then answer itself. The statement 75 is not likely a logical or mathematical error, but look at all the tokens that we spent just to determine like all this stuff, which didn't necessarily come out to any sort of an answer that we can actually like really use unless we continue the prompt along and like ask it to answer something, right? Using this information from the resolution, the considerations. So without additional context, difficult to determine if there's a missing or implied qualifier of the statement. However, it's possible the statement is meant to be interpreted with a specific context, such as range, where it might be valid. The intended meaning of a statement is unclear without additional context. It's possible that it's meant to be interpreted as a paradox or logical puzzle. So it's just giving you a whole bunch of information, but it's not necessarily saying like, this is how you can figure out, this is how you can resolve this, or is this just complete fucking nonsense? Like, you know, this answer is actually great. Like all of these things are correct, but they're not like the direction that I would want to be thinking in, right? If we're talking about an agent who can make decisions, think about the situation, and then answer, and, you know, come up with some action or something to do based off the situation. This is not it. This is not it. It needs to be something that is a little bit more, you know, I think I heard somewhere that we have verification processes in our minds, in our brains, that like take some of the information that's currently being considered and then sort of like self-check that information to make sure that that information, like it's not just random fucking gibberish or something. But again, I'm not a neuroscientist, so don't try and quote me or whatever on that. I don't really know what I'm talking about there. I'm just using how I feel that I think, you know, to try and logically create a thinking process that doesn't just fucking spam out a whole bunch of bullshit AI slop, and can actually be used for something that's a little bit more technical, and actually, you know, maybe even make some sort of like a Mistral version 2.01 model, Omni. Omni, because it's omni thought, it omni everything. It does all the things from all the places. Omni. Okay, so all right. I don't know. I mean, look at the difference between that. It spent 348 complete tokens. It spent 12 seconds. It didn't really give us. It gave us a whole list of stuff, a whole list of statements about that statement. But if you tried to take this and then push it back through, like if you were to take each thing from this list and push it back through the same prompt, you would just end up with this humongous waste of time. Okay. But over here, because, you know, there's more things to actually decouple from all of this stuff, right? Oh, by the way, these are all of our variables. You do get the completion in your variable, the completion variable. I'm actually working on an interface that's sort of like a playground interface for Prompt Owl, that you could just like load up any LLM you want in it and everything like that. But that will come. So then you have information from the variables. Like this is all direct, just raw data. So what the other one spent? So these completion tokens were 81. That other one had 134 completion tokens and took twice the time again. So user statement 75 is both greater. Statement 75 is true. That's false, and it contradicts itself. So literally we can take the word unresolvable and check for that. Or we can check for just, is the statement logically complete? Because this will always end up with NO, right? Or YES. But we can, we can easily check back and say, let's see, where were the, user statement, blah, 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 75 is less than. Where'd it go? I'll just look it over here. Complete. Oh, well, that's handy. All of the stuff that says complete. Oh, complete value, no. So I can just take this value from the result and say, does it start with an N? Or does it start with a Y? And then I have my, LLM giving me binary information back about the logical thought that it had. And then I can use that and then further do something else with that information. If it's not, but it's also unresolvable, like in the case here, then I can just essentially be like back to the user or back to the calling process, like, hey, it's not resolvable. Whatever you just said is, it don't make no sense, yo. Sorry. Or it could say back to, or if it is resolvable, then it will give back to the person or calling equation or calling algorithm or whatever. It'll give back other statements or questions that will lead to, like if you further then go, okay, I want to take this, I want to go, what's the meaning of spirit in this context? What's the meaning of have in this context? So this would push the conversation along. I think I had like there's like a whole bunch of different tests and stuff like that you could probably do here. But let's check out Mermaid. Check out the Mermaid one. Play around with these graphs a little bit. Mermaid. Okay. This is PrOwl CLI tool. Folders, prompts, charts, input Mermaid. Stops are like that. Okay. The user flow for a calendar app. Now, I didn't give it very interesting examples also to go off of, so this is like few shotting, right? This is a few shot thing. We go over here. So first off, Girdle, this was a no shot. It kind of figures that out just without any sort of example. That means that the information is sort of just built into the model itself. Whereas with the Mermaid, I had to since it doesn't really necessarily, it does know some Mermaid script, because I did see some Mermaid, some stuff that was not flowcharts, because I haven't programmed anything in here besides a flowchart yet. Oh, I did do a state diagram. But there's this other thing that it did, which is like, whoa, how the hell did you do that? But yeah. Essentially what I could do is I could just go to the examples that are on Mermaid's documentation, but I'm not going to do that. I'm just going to hang out here. All right, so oh my gosh. This is going to fail because it uses spaces. But let's just assume that we could make it, that we could take out the spaces. Just, I don't know. Yeah. Yeah. Brown. Hey, Brown. What's up? Oh, kitty cat. Hey. Is that because okay, let me just give it an extra about scripting. About scripting in Mermaid. If you are using a simple node, or a basic node, can I actually do any of this stuff with the thing? Yeah. Node, you it is within brackets if there is more than one word in the node. I think that'll make sense. And what was this? The user flow for calendar app. All right, copy. Paste. See what we get. Okay, did it thinking. Okay. All right, we got a much smaller flowchart this time. But I don't know. We'll see what happens. Okay, opening app, selecting date, adding event, confirming event, viewing calendar, declining reminder. Beam bum, beam bum, beam bum, beam. It just declined reminder and viewing the calendar the whole time. Oh, great. Sounds amazing. Sounds like a good user experience. Let's try a different one. The relationships between the C-suite of a corporation. Visually stunning, huh? Well, let's see what adds in. Graph LR. Okay. Huh. Interesting. So CEO, CFO, CTO, CIO, CEO, COO, CMO, CDO. Oh, that's how it works. In case you were wondering what all this C-suite shit is, it's I've got a whole thing where it's supposed to be like this is okay. So let's look at let's make this top down because that's what that's what it really is, right? It's top down. So the CEO sits up here, and then he has two arms, right? The CFO and the Chief Operations Officer. So the CEO sits up there. He has two arms, the CFO and the COO. The CEO is the president. I don't know what the CFO. What is the CFO? Oh. An American musical duo. Chief Financial Officer. Why would they put the CTO under the Chief Financial Officer? That doesn't make any sense. Chief Operations Officer, Chief Marketing Officer, CMO. CMO, no. See, I'm just a startup guy. I'm not a big corporate guy. CMO. Chief Marketing Officer, yeah. And then CDO, Chief Directing, CDO. Centralized debt collateralized debt obligation. C-suite. Hey there, girl. Doing? Yeah. Well. CO and the CDO, Chief Digital. Should have CO, CCO, CRO. I'm gonna go blind looking at all these CAs, CCOs, and C-O-O-O-O's. It's like literally it starts with a C and it ends with an O. Everything starts with a C and everything ends with an O. Why don't you just use the one letter that's in between? Who would just call the one person the E, one person the F, one person the O, the R, the M? Because there's only one letter to describe them anyway. Information, CMO, marketing, CDO, digital diversity or data, chief data officer. Okay. But the chief information officer is the CIO. Information or innovation, chief innovation officer. Jesus. I mean, you could really get super fluffy with the names and titles of the C-suite here, but that's it. You know, there you go. Thanks a lot, Mermaid. Anyway, so yeah, that's I think that's like really all I'm gonna do today. Let's do one more. Let's do one more. C. Okay, so let's say the C. Let's say I don't know what is a good flowchart. Flowchart for an event-driven user interface for an agenda app. Oh my gosh. Wait. For a personal trainer assistant app. I don't know. Jesus. Why am I thinking of all of these things? Why? Why are you in my mind, personal trainer assistant app? User, trainer app, exercise selection, exercise list. Seems to, oh, it has a subgraph? What the this, see, it does know Mermaid. It's just, I guess the examples that I gave it have probably made it weaker. Is details. User. Subgraph user interface. Wait, shouldn't this have like a title? I don't know. I fucked up. So maybe it doesn't know. Maybe it doesn't know Mermaid. You know. Anyway, the point is that there's lots of issues with using the smaller models, but the point is that you can get really good use out of them and not have to rely on these larger models for much faster inference on much less GPU if you just do a little bit of extra work prompting. So I will go ahead and link below the Prompt Owl. And that's just to show you here. It's just github.com/lks-ai/PrOwl. That's the one. So yeah. Anyway, please like and subscribe. Follow me. All of those other things if you like to learn more about AI and take some of these journeys with me. And yeah. Or just, you have a comment. I mean, hell, anybody, anything. Troll me, whatever, I don't care. The point is, come hang out. And thanks a lot. I'll see you soon. Till next time. Auf Wiedersehen.